touch sense is something a lot of us think about as second nature. It's on our smartphones, it's being used all sorts of places. But there are a lot of applications and new technologies that are making a difference. So, Bob, could you explain what elastic wave is and how it's going to be used in touch sensing?
Okay. Bill, thank you very much for having me here. Elastic wave is actually a type of the mechanical wave. It's sort of a vibrations, let's put it this way. So elastic wave can travel inside or on the top of the surface, such as metals. It also can travel through air, gas, or liquids. Elastic wave is commonly exist in the natural, I'll say this way. But the application and the technology we have for Taifang is mainly using for the medium such as like metal, hard metals, rigid materials such as plastics, and also the glasses. And you're asking a question about sensing technology today. How does it transform, and how does it different with the sensing technology today? Let's think about the typical sensing technology we have today. We actually using a capacitive touch IC. Normally we have IC in there and a C layer thing on the top of the surface. But we do have a little bit problem here. For example, I have a phone sitting right here, right? So this is actually using a so-called capacitive touch technology. When you just using your fingertip to do that, your fingertip is dry, which is no problem, you can do it. When you have your finger is wet or it's probably is oily, sometimes it won't work, right? Sometimes you are wearing a glove, they won't work on the sensing technology we have today for capacitive touch. But elastic wave is different. Elastic wave is when you have your finger touch the screen, it creates a vibration. It's create a vibration waveform. And we have a sensor sitting around this surface area, and this sensor can detect the vibration. Okay, once it detect a vibration, they will convert a signal into our ASIC. The ASICs. ASIC will convert those signal into sort of the data and give it to the system. So what I'm trying to say is we can solve a lot of problems that today's capacitive touch don't have, such as we can, with our technology enabled on this phone, for example, we actually you can use your fingertip with a glove, or the fingertip is wet, no problem, we can do that. The technology not only can sense the touch, but also can sense the force. The force, that means how much force you apply to the fingertip to the surface of the material. And also we can recognize the gesture, more like a patterns. Whether you do a swipe, you do a squeeze, you go squeeze or swipe and hold. So all type of textures, gestures, we can using our technology, we can achieve that. This is something the capacitive touch having a lot of difficulties.
Okay, so can you talk a little bit more about the advantages that are delivered using the elastic wave approach compared to the capacitive?
Capacitive. So just like example I said earlier. So for example, I want to give you another example. So a lot of time when you are riding a bicycle or riding a bike, you have a touch screen right here. But a lot of time, I'm just talking about the application purpose, right? So you're riding a motorbike in a windy day or in a rainy day, particularly the rainy days, right? I mean, you are wearing the gloves and stuff like that. When you want to do a certain touch on the screen, capacitive touch won't do it because it's raining, all the screen is completely wet. You couldn't do anything about it. But with our technology, we actually can make it happen, right? Because when you were riding a bike, when you want to change your speed, when you're making left or right, based on the little monitor you have in front of you, you actually just touch because the technology is only sensing the force and it will detect where is the force being applied to. So it can clearly sense the position of the touch. It can clearly tell the system how much force you have applied to. So those kind of issue we are trying to resolve. That's number one. Number two, I wanted to give you another example about wearable, the watches today, right? So we actually get a lot of customers asking for how this is using for the wearable. A lot of the heavy so-called the mountain climber, you take the watch and go to somewhere very far, and think about the weather is it's very extreme some cases. They got to wear gloves. So I just like I explained earlier, the technology can allow you to using the touch screen to touch the screen using a glove. This is something the capacitive touch will never able to do it. So those are the two so-called the major application we can think of at this moment. Of course, we can do a lot of our computers and IoT. We should have like an earbud, the TWS and earbud.
Mhm.
And like this is also probably I want to. Funny thing is, we also get a lot of inquiry from the earbud companies, because today's earbud is, I mean, since Apple has invented a lot of the earbud with a little bit gesture in there, right? So a lot of people trying to follow the same thing. So we actually can put a little sensor into our sensor and chips into the earbud right here, right? You can do swipe, you can do squeeze and hold, and we can also do different gestures using one single IC. Okay, pretty cheap, reasonable price, and I mean the IC is very little like this, and the sensor even smaller, like a 0.3 millimeter height or something like that. So it's a very small size, and so we can definitely can do a lot of good things for the consumers. This is something we want to drive, and make sure we can deliver the good results to the customers. And again, we get a lot of inquiry for that, Bill.
Great. So are there any metrics that could convey how much this approach improves the touch sensing application?
So one thing I want to clarify here is our technology can do its own sensing of the touch,
Mhm.
but same time they can work with other capacitive sensing supplier as well. So for example, when we design today's touchpad, I mean, today we have touchpad. In the future, we will have a force pad. That means you have a touchpad functionality, which is still capacitive, type of the touchpad, but same time, the customer or the system, they want to have a little bit of feedback when you put your finger on top of the touchpad. So it's kind of vibration or haptic kind of sensitivities, right? So they want to have something like that. So we can work with the current touch pad supplier to having their touch IC in the system. We are providing the haptic solution into it. So it become it's a combination of current existing technology plus our new advanced technology to provide a haptics feeling, and we can provide total solution to a customer. This is something, it's kind of innovative to my point, and we're actually testing a lot of consumers today. For example, LG has already launched our products early this year.
Oh, very good.
Yeah.
So you also have something called TAIPS for the
Right.
automotive market.
Right.
Is this the same technology? How does it work?
It is a very similar technology. So TAIPS stands for Taifang Automobile Intelligent Perceptions. We're using a very similar technology using for auto. These TAPS is only using for auto. So we're using 100% the application. If we talk about tablet, it's for auto.
Mhm.
So the theory behind that is we got to put some sensor in the bumpers and also on the doors, right? So we also have a little so-called central controller module somewhere sitting in the cars. So basically, if we see a kind of a vibration or we experience kind of a collision, something happen on the the front side or on the body side, on the bumper side, the front and rear bumpers, the sensor will detect this kind of vibration. The sensor will send a vibration signal to the what we call ASIC. We have ASIC for that, special ASIC for auto industries, and ASIC will translate this kind of signal into the digital signal we were feeding back to the car systems. So for example, somebody want to bring your car and they want to, getting close to the car, they want to slam your windows, bam, the signal will be generated and sent to the central system. The system can send the signal to the front camera or back camera to see who is doing that. At the same time, the system can send a signal to 911 or send to the owner of the car to let them somebody's trying to break your cars. So this is just give you one example. The other example, of course, if somebody is getting close to you, somebody, a bike is trying to get a scratch or something like that, the sensor will detect it. Definitely will tell the system there's something happened on the rear side of the bumpers or front side of bumpers. I mean, all type of different application is quite useful. Bill, one more thing I want to give you another example. We also get some inquiry from a rental company, the car rental company.
Mhm.
what's happening is we have interesting. We get a call from a company, in China. We're telling, hey, can you guys help me to, we get a lot of complaint, from customers say, this scratch is not caused by me. This dent is caused by me. It's a lot of argument back and forth between the car rental company versus the customer trying to rent a car,
Mhm.
right? Using our technology, we actually can clearly tell the customer in what day, in what time, what was happening, because every single, so-called whatever the collision or dent, or kind of so-called cause any mechanical vibration to the bumper and to the doors, this information will be logged into the systems, right? So it's a great effort. It's a great advantage for a rental company to tell the customer, hey, hey, I'm telling you on what day and what time this scratch is caused by you, right? So this is a lot of advantage for the car industry today. They were trying to take advantage of our solution, and it's quite cheap as well. I'm a low cost solution to them. So, and also, for example, we have two companies already. One company already launched our products in China. They probably, to be precisely, they launched the products in March and April. Just launched their vehicle with our solution, and the other company is also very reputable companies. I won't mention the name. They are actually doing a lot of development with us. We expect to launching our solution in their car by end of this year.
Mhm.
So again, auto industry is it's a very big market. Once we're getting into it, once we get acceptance from the auto industries, this is going to be huge on that. Particularly, everything goes smarter in the futures. This is something we can see big advantage and big future for us.
Well, very good. Thank you very much for explaining elastic wave touch sensing technology.
Thank you, Bill.